How do you calculate the discriminant with fractions? Imagine you're solving a quadratic equation that has fractions in its coefficients. It might seem tricky at first, but with a few simple steps, you can find the discriminant just like with whole numbers. The discriminant helps us understand the roots of the equation. It is calculated using the formula. The discriminant equals the square of the coefficient of the middle term minus 4 times the coefficient of the quadratic term times the constant term. When fractions are involved, the main thing to remember is to handle the fractional coefficients carefully during substitution and calculation. First, identify the coefficients in your quadratic equation. These might be fractions like 2/3, 9/4, or 5/3. To make calculations easier, you can clear the fractions by multiplying the entire equation by the least common denominator of all the fractions. This step is optional but helps avoid confusion. Next, substitute the fractional coefficients into the discriminant formula. If you have fractions, remember to square the numerator and denominator separately when squaring the middle coefficient. When multiplying for the first coefficient and the constant, follow the rules for multiplying fractions. To subtract, find a common denominator if necessary, and then perform the subtraction. For example, take the quadratic equation 3/2 x squared minus 9/4 plus 5/3 equals 0. The coefficients are 3/2, negative 9/4, and 5/3. First, square the middle coefficient. Negative 9/4 squared equals 91/16. Then, calculate for times the first coefficient times the third coefficient, for times 3/2 times 5/3. Multiply the fractions step by step. For times 3/2 equals 6, and 6 times 5/3 equals 10. So the discriminant is 91/16 minus 10. To subtract, convert 10 into 16ths. 10 equals 160 divided by 16. Now, subtract. 91/16 minus 160/16 equals negative 75/16. The negative result shows the quadratic has two complex roots. Alternatively, you can eliminate fractions by multiplying the entire equation by the least common denominator, which in this case is 12. Multiplying through gives you a new equation, 18x squared minus 27x plus 20 equals 0. Now, calculate the discriminant using whole numbers. B squared is negative 27 squared, which is 729. For times a times c is for times 18 times 20, which equals 1,440. Subtracting gives you 729 minus 1,440, which equals negative 711. This negative discriminant again indicates two complex roots. Remember, if the discriminant is positive, the quadratic has two different real roots. If it is 0, there is exactly one real root, called a repeated root. And if it is negative, the roots are complex numbers. Calculating the discriminant with fractions might seem complicated at first, but by carefully managing fraction arithmetic or clearing the fractions beforehand, it becomes straightforward. This process reinforces the importance of careful calculation and understanding how the discriminant reveals the nature of the solutions in quadratic equations.